Hello. All right. Hey, everyone. Thank you so much for coming to my talk today and tell you a little bit about some of the changes that we've observed in ransomware over the past couple of years. So to start off, I'm Lindsay Kaye, Senior Director of the Advanced Reversing Malware Operations Reconnaissance Group at Recorded Future. So I run the technical arm of our threat intelligence team, and by trade, I'm a malware analyst and reverse engineer. So let's start off on the premise that just like the rest of us, ransomware groups are also subject to the realities of the economy. So sometimes we see them innovate their tools or behavior in order to remain successful in a very competitive market. They can't simply just build it and the affiliates will come to them. But like some other less successful innovations of the past, sometimes these changes don't really work the way that the threat actors intend, and sometimes we see them backfire. So today, I'm going to tell you about a couple of these innovations that we've observed in ransomware and talk about what made them particularly successful or much less so. So we observed several different types of changes in lockers that ran in ransomware threat actor TTPs over the past couple of years. So things like new lockers will start to come out, people add additional features to existing ones. We see new ways of deploying and spreading them. Different languages start being used, so it's not just C and C++ anymore. So we'll start seeing things like Golang, Rust, and Python, name a couple. We see new and creative extortion methods to really make people want to pay, and the targeting of additional hardware. So some of these worked particularly well. So first, some of the deployment improvements. So by and large, we've seen threat actors move towards using things like benign tools and kind of the artifacts of how the operating system works to spread their ransomware. So previously, you would see a lot of kind of like custom tooling, which is a lot easier to detect if you're looking for something that's bad, whereas it's a lot harder to detect anomalies in these tools that you expect to be there. So for example, MSPs, and the Kaye incident comes to mind as well. Using SMB shares to move laterally, CIFS and NFS are also another couple examples. And one of the other things that we see ransomware threat actors do is they'll start to build in impersonation tokens into the actual locker so it can spread itself. Next, threat actors have had some particularly good success optimizing what they already have out there in the market. So things like intermittent encryption, which I'm sure we're all familiar with, and adding additional functionality to lockers based on affiliate demands to try and attract affiliates to their program. Next, it's always helpful to fill gaps in the ecosystem. So after Revil and DarkSide disbanded due to a couple kind of high-profile attacks on JBS Foods and Colonial Pipeline, if you remember those, we saw Black Matter and Conti also put out Linux and ESXi lockers to kind of fill that gap. Then we saw Alpha add in something called a chat access code, which I'll talk about later, to minimize the threat of chat hijacking. Things like making their exfiltrated victim files searchable, so much easier to start going through what threat actors have access to rather than just trying to click file by file. And finally, that they made their panels more user-friendly. So adding features like built-in Bitcoin mixers, allowing affiliates to put in support tickets, and then helping them moderate victims after a successful attack. Additionally, really trying to make them pay is a great tactic. So some of the additional extortion techniques that we saw were things like DDoSing people who wouldn't pay, calling their board members and their clients to let them know something's happened, and contacting the media to make it more widely publicized. And additionally, we all kind of find some amusement in the idea of printing a ransomware note on the local printers, but really kind of the functionality of that is if the organization is trying to hide from their employees and those around that something bad has happened, it's a lot harder to do so when the ransom note is spewing out of the local printers rather than just kind of like a file on somebody's desktop. However, some of the innovations we saw really never took off and left something to be desired. So we always say, like as developers, don't roll your own crypto. DarkSide and Black Matter both learned that the hard way when they had encryption flaws. A lot of threat actors seem to want to do some sort of false flag attribution, which we'll talk about, and they don't always succeed in doing so. Sometimes you'll see threat actors add things like to make the tool harder to reverse engineer or adopt other threat actors' tools, but ultimately they just end up making them more signaturable by doing so. Making it so secure no one can use it. So one example is Black Matter, if you remember them, had required a Tor private key to access their affiliate panel. So this was above the kind of technical expertise of a lot of their affiliates. So obviously, if you make it harder to access your offering, you're not going to get as many customers. And then finally, letting politics get involved. As we remember with the Russia-Ukraine invasion, Conti sided with Russia, which displeased some of their members and led to ultimately kind of the final destruction of the group. So in the spirit of Dua Lipa, we're going to talk about some of the new rules of being a successful ransomware threat actor in this day and age. So play ransomware. might be familiar with it. It's relatively new, but it's fairly active. And we first saw it we first observed it in June 2022. Like much ransomware of the past, it's written in C++, and it was first used in a cyber attack against the Argentina court of Cordoba in August 2022. So some of the notable features here. So this very minimal ransom note. So if you've ever looked at other ransom notes in the past, this should kind of stick out to you. Usually you'll have a lot of text about what happened, how do you pay, what are the repercussions of not paying, but this is it. So fairly unusual here. I'm going to talk about the addition of return-oriented programming, ROP, and other added obfuscations and their impact, and then how they did intermittent encryption. So ROP and ransomware, yeah, I was surprised too. So this is not something that I had ever really seen before, but it was particularly interesting. So in case you're not super familiar with what ROP is, ultimately in this case, it functions to make reverse engineering a little more challenging and to some degree acts as a control flow obfuscation technique. So basically what happens is it takes advantage of kind of the artifact of how the return instruction works. So you can see on the right an example here. So increment ESP by 32 and then do a return. So what this causes is that you'll do then a jump to the next piece of code that you're going to execute. So between the return instruction and that new code, there's a bunch of just kind of garbage code. Gator doesn't really like that, so it just kind of gets a little confused. So you can kind of fix it up there, but ultimately slightly more challenging. So you can see on the left an example of the play code without ROP, just to kind of set that stage. So if you're a threat actor, adding obfuscation is totally great, but really consider doing it from the start. So the first play samples that I looked at from mid-June 2022 had some obfuscations to them. So pretty simple string obfuscation you could see on the top right. They used API hashing, again, to make it harder to statically reverse engineer like which APIs are being called when. But ultimately, the code itself was not wildly challenging to reverse engineer. The additional obfuscations really only came in August 2022. So first, the return-oriented programming, like I mentioned, and then they had some garbage code insertion, which you can see on the bottom right. So while ROP was definitely a positive addition to make the code harder to reverse engineer, ultimately, the code was still the same underneath. So if you're struggling to reverse engineer the obfuscated one, just kind of look at the unobfuscated one and you're kind of off to the races. So it makes it really easy to start picking out the artifacts that you're looking for and of interest in the new code. Additionally, I was able to write a rule to look for artifacts of the automated garbage code edition that were pretty signaturable to be able to find new versions. It's probably an automated technique, which made it easy enough to start looking for other samples that used it. Also, if you're a threat actor, make sure you're giving the people what they want to make your offering the best on the market. So Play Ransomware, like many other groups, uses intermittent encryption. So what this is that every other 1 megabyte of data, they'll encrypt. So this is something they included from the start in June 2022. But what it functions to do is make encryption faster over large files. So the idea of making your encryption faster is that you can probably inflict substantially more damage before somebody figures out what you're doing and tries to stop you. So ultimately, more profit. And doing it in this way, that every other megabyte rather, makes it substantially less recoverable than some groups that just encrypt the first, couple of megabytes and then leave the rest unencrypted, which for extremely large files, you can imagine how that leaves a lot of the file recoverable. Other groups do it too, maybe in slightly different ways, but people like Agenda, Alpha, and Black Bass. So this is a fairly common technique. Speaking of Alpha, Alpha is a rebrand of Black Matter. So their code is written in Rust, which is fairly unusual, and they were first discovered in December 2021. So they're known for multiple attacks on infrastructure. So back when the group was originally DarkSide, before they became Black Matter and then Alpha, they attacked Colonial Pipeline, which was a huge issue in the US. People all freaked out. But they're also known for a lot of other attacks as well. And some of the notable features here, so they were the first big ransomware written in Rust, first big ransomware with an ARM locker. They have an interesting build obfuscation toolkit called Morph, which I'll talk about. They use chat access tokens to mitigate the threat of chat hijacking. And then they have their searchable victim files index called Alpha Collections. So you can search by content, file name, different things like that. It makes it easier for them to share the results of their ransomware attacks with the community. So the idea behind the chat, the Alpha access tokens. So when the group was Black Matter, there was a pretty well-known chat hijacking incident. And what happened there was the threat actor obviously was trying to negotiate with the victim of the attack. And what happened was that some researchers found a sample in VirusTotal, detonated it, and then found the link to the chat. So they and a wide variety of other people went in, pandemonium ensued because the threat actor couldn't tell who they were negotiating with and had to ultimately end the chat. So in order to spin up the proper victim chat, they had to require domain controllers and domain admin information to find out who the real victim was. So after that group disbanded and they became alpha, they built a locker to require something called the access token. So this is generated at build time, and ultimately what it does is it is used to generate the proper chat link so that only the victim who is intended to be in it has it. So if you find this random sample on VirusTotal and you try to run it with another access token, you'll generate something, but it won't be the right link. So ultimately, being able to create a more secure line of communication with their victims in order to prevent an incident like that happening again. So why Rust? So this is the first big ransomware written in Rust. So usually you'll see like C, C++, Delphi, Golang more recently, which we're all familiar with. Fickerstealer is a really popular stealer also written in Rust, but really no other ransomware at that time was. So the nice thing about it is it's cross-compilable. So you can build one set of code and get a Windows, Linux, and ARM locker out of that code. And as a bonus, one I'm personally familiar with, reverse engineering is a little bit harder. Well, at least for now. So some of the complications here are that library functions aren't always identified. So when you're doing reverse engineering and you're trying to find the interesting code to look at, it's a lot harder because there's just a bunch of library functions and you don't want to be like caught reverse engineering, some sort of string allocation for 20 minutes. So you have to kind of figure out what's the interesting stuff here. There's also a lot of runtime code in the binary, so things like error handling. So you can see on the top right there, it doesn't make it necessarily insurmountable, but it's just a lot more stuff to look at, kind of at the time you're doing reverse engineering, and it's a little bit more kind of cluttered. Additionally, like Golang, strings are not null terminated, so what this ends up doing until you do some sort of post-processing type fix-up, you'll start to see all the strings sort of run together, as you can see on the bottom right. So some of your references get a little screwed up until you post-process them. And at this time, fix-up tools are substantially more nascent than they were for like Golang. So if you remember when the first kind of Golang malware was coming out, we were kind of in that same situation, but now many researchers have put out nice utilities for other people. And yes, I did mention an ARM locker. So the way that they advertised it was that it was designed to target NAS devices. So if you've heard of QNAP, Synology, and other things like that. So this would not necessarily be something you use kind of in a vacuum. You would generally want to use it in parallel to your Windows and Linux's ESXi lockers. So now, instead of just kind of getting people's ESXi servers and their Windows machines, you're also being able to target the backups and uncommon file shares that they have. So ultimately, you're increasing the effectiveness of the ransomware attack because things that a company might have thought wouldn't be encrypted now run the risk of being so. And to date, haven't observed it used in the wild as yet, not to say that it won't be, but that's just where we are now. And generally, ARM lockers aren't really super common to see. So Chaos Ransomware has one, but if you look at the other kind of like mainstream groups, there really aren't any. So the Morph Obfuscation Toolkit I thought was pretty cool. So the way that they advertised it was this is something that will help evade AV. So what they promised was garbage code insertion and string obfuscation to make it harder. Cool. So this is what their string obfuscation looks like. They have a 1-byte XOR key randomly generated, and you can see an example of some of that garbage code insertion there. Largely, I guess, global address, some like mathematical operations that have no salient effect on the actual code. So the only kind of like real piece of code in there is the XORing with 8. So one of the interesting things is like, okay, it was as promised, but binaries were substantially bigger. So all the original Golang binaries are about 3 megs apiece. These obfuscated ones were close to 14. So largely, a lot of the increases were in the text, data, and relocation sections because of kind of the artifact of what they were doing. However, if you're being a threat actor, make sure you check your work. So they also had Morph obfuscation for their Linux binaries. Fantastic. Didn't observe any string obfuscation, but kind of the other really interesting thing is Generally, if you're doing reverse engineering of this kind of stuff, like there are no function names, because as you know, that makes it substantially easier to figure out what's going on. So you can see on the left an example of the unobfuscated binaries, no function names, no export names containing the word locker. Cool. So after the morph obfuscation was applied to one of the Linux binaries, what I noticed is something that looked like name-mangled function names to some degree that actually had the words blocker, core, like kind of started to give you some of the idea of what the original function names were. Makes it a little easier to reverse engineer. Not entirely sure if that was intentional, probably not. But to date, this is no longer an offering. Not entirely sure why. But no, really, check your work. So it's not just in kind of the obfuscations that people are doing, but we've seen several threat actors actually screw up the encryption and decryption, which is where they make the money and probably where they should not be screwing up. So everybody's probably familiar with the ESXi ARGs kind of attacks, I believe 2 weeks ago now. So version 1 was interesting. So the way that they tried to do their, for lack of a better word, intermittent encryption was they would encrypt 1 megabyte and skip X megabytes based on a calculation that X was approximately 1% of the file size. So fine if it's a small file, but if you're looking at a file that's 450 gigs, then you're skipping about 4.5 gigabytes at a time. So this made recovery possible for these very large files, which is kind of not what you want if you're trying to extort somebody into paying. But they weren't the only one. So Luna Ransomware also has an ESXi locker, circa about 2022. And one of the things that most people with ESXi lockers do is they will shut down the VM and then encrypt it. However, they just encrypted them without shutting them down. So while this won't always lead to corruption, it's pretty plausible that after trying to decrypt it, lead to corruption, and then the victims now paid you to decrypt their stuff, and you kind of broke it. Not good for business. Next, back to kind of black matter and dark side in 2022. In 2020, they decided, let's roll our own crypto, and ultimately there was a flaw in it that allowed researchers to be able to help decrypt the victims without requiring payment. So succeeded in the attack, victims decrypted without the payment. Not great. And then finally, Ryuk ransomware from 2019. So they had a buggy decryptor that didn't work on large files. So as you can see, this is definitely something that kind of keeps cropping up and will probably crop up again in the future. So LockBit. So everybody's probably familiar with LockBit. They're one of the most active ransomware groups right now, and their original code is written in Origin C. We first observed them in September 2019, so a while now. And there's a couple of attacks that they've conducted that you may have heard of. So some of the most interesting things about them is they have the SteelBit victim file exfiltrator, which I'll talk about, that they have tried to recruit insiders from companies that they were attacking. So pretty much what they do is they say, hey, we'll give you some money if you provide us initial access to this company, which is not something I really have seen other threat actors do. And kind of some interesting thing that happened when their builder was leaked. So after Black Matter fired all of their developers based on their encryption flaws, it looks like LockBit acquired, so rumor has it, acquired their code, and then put out an offering called LockBit Black. So after that, another rumor has it that the disgruntled developer actually got mad and leaked the LockBit Black code. So the good thing about the code is that it has a customizable configuration, so anybody can modify and build code from it. However, this also started to enable some ransomware group spinoffs. So take builder, build code, make your own offering. So bloody ransomware is kind of one of the ones that kind of recently cropped up. In addition, it seems like LockBit kind of has a trend going here. So something called LockBit Green recently came out based on the leaked source code by the Ukrainian researcher for Conti's offering. So from this code, we saw a new ESXi variant, and we also saw some of the Tor-based URLs that belong to LockBit in the samples. So this is not just another group kind of building with this builder or kind of Conti reemerging. It's like this is something that LockBit has now taken and used. So I looked at LockBit Black, and one thing that stuck out is, yes, it does look very much like Black Matter's ransomware. So you can see the entry function, so just as kind of an example of what similar looks like. So the one kind of salient difference of the LockBit Black code was the do decrypt function that you can see all the way at the top on the right. So if you're a threat actor, you could totally borrow other people's stuff, but really try to improve it to your own for your own needs. So some of the similarities here were the high-level structure of the code. So just kind of looking at it, about the same control flow, kind of same functionality in the same places, what you would expect if code was pretty similar. The API hashing technique they used, the string hashing. So one of the things that Black Matter did, and now LockBit Black, was instead of doing like string comparisons for the incoming function name, for the incoming arguments, or like if they were looking for particular printers or other kinds of strings, is they would take a numeric hash and then compare it to like a list of no numeric hashes. So that was something that they both did. The way the configuration file was decrypted, and then some of the anti-debugging techniques that they used. So not just this one, but crash if breakpoints placed on its thread, as well as kind of that combination thereof. But there were also some differences, which you could largely count as improvements. So some of the LockBit Black versions actually do require a password to decrypt. So can't really run them unless you have, or can't run them properly unless you have the right password. And they started implementing additional command line parameters. So in addition to the kind of the known ones that Black Matter had, they also have now group policy modification and self-deletion, and a couple others as well. And additionally, they have some different configuration data flags to support some of this additional functionality as well. But are they going to keep improving on their lockers? So after the release of LockBit Black, we really haven't seen any salient changes to their original locker. We did see kind of the advent of LockBit Green, particularly interesting, but it seems like maybe their business model is slightly different from some of the other threat actors who you largely see kind of iterating on the same set of code until they disband. It's just kind of interesting there. So kind of one point is that some of the samples of LockBit Black don't have that decrypt function in there, and they don't require the password to run. Seems like that's an option that the builder just provides. You could see an example of what this decrypt function looks like on the right. It's pretty much the same in all of them, so definitely believe that. For what it's worth, another threat actor group, Gregor, from almost 3 years ago now, used some of the password-based decryption of their malware pretty successfully. So made it a lot harder to find a sample to reverse engineer if you just couldn't get the code out. And kind of one of the bonuses is that StealBit is their automated data exfiltration for victim files. So ultimately, many ransomware threat actors will steal victim data, post it on a leak site, and then use that to extort victims. So this is just kind of a nice automated tool that they have to exfiltrate the files and automatically upload them to their leak site. So another kind of interesting trend that LockBit is certainly a part of is the idea of trying to false flag, instead of as a Russia-associated group, as a China-associated group. Interesting. So when Recorded Future actually interviewed LockBit and raised some concerns about what happens to people who live in Russia or the US in the interview, they advised that they certainly live in China and that none of their affiliates live in the United States or Russia, so these aren't concerns of theirs. Interesting. So this is not kind of just them. So sometimes you'll see threat actors post machine-translated Chinese asking about ransomware on some forums. So you can see on the bottom right an example of one of these things. So I talked to one of my coworkers who speaks Chinese, and he was like, this is not right. So in case you're super familiar, that's kind of not great, and kind of the tone is super incorrect for what you'd expect. Other forums like RAMP, pretty popular forum, really also tries to welcome Chinese speakers. So they're really trying to attract Chinese threat actors and ransomware gangs. Not entirely sure why, but that's kind of what that looks like. So sometimes this doesn't always kind of work out, and they don't really do a great job of kind of like executing on the false flagging. So Yanlu Wang was a ransomware group that purported to be China associated, but what happened was that a lot of their chats were leaked, and it was discovered that the conversations were in Russian, not Chinese, so probably not Chinese associated. So if you're trying to false flag and you want to be successful at it, make sure you don't cut corners. So here is some ransomware that purported to be Shao ransomware. Cool, detonated it, saw what happened. You can see at the top, the note kind of has some like sort of references to, maybe things that aren't Russia associated. Interesting. Then I looked at some of the terminal output, and what you notice is that it says Revix 1.1c. So if you're not familiar with Revix, back in the day, Revil had a Linux offering called Revix. Looked at that code substantially. This looks exactly like it, and it looks like they just kind of reskinned that. So probably not China associated, because I don't believe Revix was ever leaked. So there you go. So now we want to kind of hunt for these things, and it's kind of what our goal is here. So one of the things, if you're trying to look for additional badness, is start to face the strange. So a lot of the automated obfuscation techniques do leave some artifacts. So for example, with plays, additional garbage code insertion, some of the ways that generally they work to do that, you'll start to see in like some of the ROP stuff, like there's a pattern to it, some of the alpha morph stuff as well. Ideally, it's better if these techniques are custom, so they've written them themselves rather than kind of downloading a toolkit. I guess depending what you're sort of looking for, do you want to find more people using the toolkit or more of these things? Also looking for inconsistencies in like language that they use, especially for strings. So like blog messages, any sort of mutex names, anything interesting there that kind of sticks out is pretty successful. A lot of the times you can also look for the text of the ransom notes. So sometimes you'll see kind of interesting turns of phrase. For example, if you know that there's a Windows locker, you can look the ransom note and potentially find something like a Linux locker, an ESXi locker, if they have one, sometimes based on just kind of those language artifacts. Additionally, another kind of fun technique to use is looking at their anti-reverse engineering, anti-debugging, or anti-analysis techniques. So not all the time are they unique, but sometimes what you'll see is kind of its unique and interesting combinations thereof. So that's a good place to start as well. Implementation of the crypto algorithms, especially if it's wrong or kind of a weird combination of them. So for example, dark side and black matter both had the encryption flaw, but another thing that they did was they kind of had a weird combination of which algorithms they were using that researchers ultimately were able to kind of link them based on. Additionally, buggy anomalies. So anything that doesn't work the way that it should, or code that's just kind of not working. So generally, my understanding is that if you're trying to have successful ransomware, you want it to work and function as expected. So if it's not, probably not their intention. So something else to kind of pivot on and look for. And staying up on the latest affiliate news. So you can see on the right, Alpha's announcement of the Morph toolkit. So this is something that you can see and you say, okay, interesting. Let me try and find something like that, or try and figure out a different way to find it, or figure out some way to get access to it myself. But kind of with all these like leaked builders and things coming out now, another interesting technique is to look for code reuse between families. So like we saw with the LockBit Green and LockBit Black, and then other people kind of using those, you start to see a lot of kind of code overlap. Might be useful if you want to say, okay, who else is using Conti's builder? What other offerings are kind of out there right now? And then looking for other kind of overlaps in ransom note language. So sometimes that's kind of like fun to look for. Generally, you'll see things except for like play, right? What happened, your network, Tor project, other verbiage like that. So if you're trying to look for additional ransomware out there. And with that, are there any questions?